Power amplifiers are meant for enhancing the power level of a signal. They are used both in electrical communication transmitters and receivers. In transmitters, they occupy a position just before the antenna. In receivers, they occupy a position just after antenna and also just before the end of receiver chain. Power amplifiers are large signal amplifiers. They cannot be put into small signal category. Hence, two serious issues arise. One is the equivalent circuits that are developed assuming small signal conditions. They are no more valid to analyze these amplifiers, as these amplifiers deal with large signals. This is one aspect. Another aspect is the techniques that are developed for the analysis and design of small signal amplifiers. They are no more useful with these amplifiers. New techniques, they are developed and they are used. When it comes to power amplifiers, two serious aspects that are considered, taken seriously are: one is efficiency, another is distortion. The fact is that when we go for more efficiency along with high efficiency, we also find more distortion. If we opt for clarity, lesser distortion, then along with the lesser distortion, we also find lesser efficiency in these amplifiers. Electronic circuits for amplifiers, part 1, series on semiconductor devices and circuits, lecture number 8.18. Power amplifiers are amplifiers capable of handling large signal powers. They are designed to deal with signals of large amplitudes. They are usually last stages of amplifier chains, which actually drive the load. Two important features of power amplifiers are: one, they work in non-linear region, and hence equivalent circuits that are developed assuming linearity. They are not suitable for the analysis or design of these amplifiers, power amplifiers. Another aspect, another specialty of power amplifiers is they generate huge amount of heat. Unless appropriate techniques are implemented for the removal of heat from the circuit, temperature may rise to higher values, leading to deterioration of the performance of the amplifier, and sometimes it may even lead to burnout. In the present session, the focus is on definition of a power amplifier, important features of power amplifiers, classifications. Two classifications are there, both are given, and along with we also describe one type of amplifiers, class A amplifiers, here in this session. Now let us move to begin the core session. Let us start the session with some general points on power amplifiers. Amplifiers designed to increase the power of an input signal. Power of input signal, they are called power amplifiers. Amplifier provides enhancement. If the enhancement is in voltage, they are voltage amplifiers. If the enhancement is in current, they are current amplifiers. Here the enhancement is in the power level, hence they are called power amplifiers. These are capable of delivering large amounts of power to load. Power amplifiers are usually output stage of multi-stage amplifier chain delivering large signal power to the load. Notice large signal means amplitude wise large, power wise also large. Many of the equations so far developed assuming small signal operation or linearity of operation are no longer valid because device parameters change with large signal operation. Signal distortion occurs because of change in amplifier characteristics with signal level. So distortion, good amount of distortion, significant amount of distortion is an important feature of power amplifiers. Harmonic distortion always results due to onset of non-linearity in the operation of power amplifiers. So distortion is not insignificant. This is one aspect. Harmonic distortion is an important aspect in these amplifiers. Here are shown some mechanisms, certain schemes by which it is removed from the transistor, power transistor. Here is a cap, metal cap. See, this is transistor. Inside the cap, transistor is there. When transistor is functioning, heat is generated. That heat is immediately conducted to the cap, and this cap then sends out into the surroundings. It radiates. So it is the way things work when it comes to cap, metal cap. Here is another scheme, another arrangement. This is metal. This is transistor. It generates heat while functioning. This heat is then absorbed by the metal piece and then it is radiated into the surroundings. In this way, the temperature of the transistor is prevented from rising. Another arrangement is shown in C. It is heat sink. This is transistor. It generates heat while functioning. That heat is then conducted or it is radiated into the surroundings by the sink that is shown here. Notice heat gets radiated more and more into the surroundings when the surface area of the radiator is large. In all these arrangements shown in A, B and C, notice the radiator is designed in such a way that it has more surface area. Now some points regarding applications. Power amplifiers are widely used in audio systems like radio and television receivers, phonographs, tape players, stereo and high fidelity systems, recording studio equipment, public address systems. So mainly audio systems. Audio, what is audio? Audio is a signal that can be detected by human ear. Speech and music are two parts of audio signal. In these applications, the load usually is a loudspeaker, requires a good amount of power to convert its input electrical signal into load. The power amplifiers are also used in electromechanical systems like computer disk and tape drives, antenna, rotators, pumps, motorized valves, etc. etc. Plenty of applications are there for power amplifiers. In this slide, we consider one or two performance indices of power amplifiers. The first one is conversion efficiency. It is the ratio of AC output power to DC input power. First thing is, it is powers ratio. Efficiency means output by input powers. Conversion efficiency is AC output power to DC input power ratio. Eta is the symbol P1 by PDC. P1 is AC output power, PDC is DC input power. Another parameter, important parameter is power dissipation capacity. Ability to scatter large amounts of heat that is generated during its operation into surroundings. Notice this heat generation is a serious problem. In fact, it is a very, very serious problem. It has to be addressed. It has to be taken into account while designing power amplifier circuits. It is an important part, important component, important aspect in the design and functioning of power amplifiers. How well arrangements are made to remove heat from the amplifier immediately after its generation, preventing the rise of temperature, is an important aspect. This aspect is indicated by power dissipation capacity. Another aspect is distortion. Power amplifiers are always associated with distortion. In some amplifiers it may be less, in some amplifiers it may be more, but it exists always, and it exists in serious amounts. So this aspect also has to be taken into account while designing power amplifier. What is distortion? Change in output wave shape from its input wave shape is called distortion. Wave shape is an important aspect. Its importance can be understood from the fact that information in the signal is stored in the wave shape, in its wave shape, in the wave shape of the signal. Wave shape deviation, wave shape change, alteration means loss of information. So distortion is loss of information. It is a serious issue. Classifications are there. Two classifications as far as power amplifiers are concerned. One classification is based on operating point or conduction angle. Based on operating point conduction angle classification, they are divided into A, B, C, E, F, G, H. Some more letters are also there. But most important classification is into 4. A, B, C. These 4. Another classification is also there. It is based on frequency of operation. Divides power amplifiers into 3 categories: audio, radio, DC. Audio means it is frequency band of a signal which can be detected, which can be sensed by human ears. Radio means wireless. Literal meaning of radio is wireless. DC means direct current. Here is shown details pertaining to first classification. Classification based on location of operating point or conduction angle amount. Class A, Class B, Class AB, Class C. In Class A operation, conduction angle is 360 degrees. Class B operation, conduction angle is 180 degrees. For Class AB, it is more than 180. For Class C, it is less than 180. What is 360 degrees? 180 degrees, more than 180 degrees, less than 180 degrees. This aspect we discuss, I will show you in the next slide. Bias point location. For class A operation, point is located deep in linear region. For class B operation, it is located over the edge of the cutoff. For class AB, it is located in linear region but near cutoff. For class C operation, it is located deep within cutoff. Efficiency for class A operation, efficiency is 50 or 25. There are two ways by which class A can be implemented: series fed and transformer fed. In case of series fed, it is only 25%. In case of transformer coupled load, it is 50%. Note these figures: 78.5% for class B, less than 78.5% for class AB, 90% for class C. These are all theoretical figures, maximum possible theoretical values. In practice, achievable efficiency is very, very small. For example, for series fed, it is not even 17%. So actual or real efficiency levels are very small when compared to the figures that are given here. These operations are also associated with certain drawbacks. Class A is associated with low efficiency. Class B, one type of distortion, crossover distortion. In class AB, efficiency is less. In class C, distortion is more. Notice when it comes to efficiency, it is increasing from class A to class C. When it comes to distortion, we can also notice distortion increasing continuously as you move from class A to class A. So efficiency increases, distortion also increases as we move from class A to class C. The classification that has been given in the previous slide, it is based on conduction angle. What is this conduction angle? Let us suppose input signal is sinusoidal. Consider one cycle. It consists of two half cycles, one positive half cycle, another negative half cycle. The span of positive half cycle is 180 degrees. Span of negative half cycle is another 180 degrees. Total span is 360 degrees. If the full cycle is amplified and appears at the output terminals, then we say conduction angle is 360 degrees. If only one half cycle is amplified and appears at the output terminals, then we say conduction angle is 180 degrees. If more than one half cycle but less than full cycle is amplified and appears at the output terminals, then we say conduction angle is more than 180. If less than one half cycle is amplified and appears across the output terminals of the amplifier, then we say conduction angle is less than 180. Here in class A is shown class A operation. Why it is class A? The conduction is 360 degrees, positive half cycle, negative half cycle. Total cycle is passed through the amplifier. It got amplified while passing through the amplifier and it is appearing across the output terminals. Total cycle, complete cycle, 360 degrees. That's why it is class A. In B diagram is shown only one half cycle, positive half cycle. It can be negative half cycle also, but in B is shown positive half cycle. One half cycle means pi, 180 degrees. Conduction angle is 180, that's why it is class B operation. In C is shown waveform whose duration is more than pi. You see, it is from less than 2 pi to more than 3 pi, it means more than pi. So it is class AB operation. In C is shown conduction of the waveform, which is less than half cycle, 1/2 cycle. So it is class A operation. Another classification is there. According to this classification, we have already seen power amplifiers are divided into three: audio, radio, and DC. A few points regarding audio power amplifiers. Audio power amplifiers raise the power level of signals that have audio frequency range. As already mentioned, audio means frequencies that can be detected by human ear. Frequency range 20 Hz to 20 kHz is considered to be the audio. These are also known as a small signal power. This small refers to power, signal power, not amplitude. So they are also known as small signal power amplifiers used to drive speakers in TV sets, mobile phones, etc. Their output power levels range from milliwatts to kilowatts. Radio power amplifiers. Radio power amplifiers are tuned power amplifiers that raise the power level of signals that have radio frequency range. So radio means wireless frequencies that are used for wireless communications. They are called radio frequencies. 3 kHz to 300 GHz can be considered as radio frequency range. They are also known as large power amplifiers, large signal power amplifiers. In wireless communication systems, these amplifiers are used to drive the antenna. Their output power levels range from kilowatts to megawatts. Kilowatts to megawatts. This is the reason for these amplifiers being labeled as a large signal power amplifier. Next, DC power amplifiers. DC power amplifiers are used to amplify the power of a PWM, pulse width modulated signals. They are used in electronic control systems which need high power signals to drive motors or actuators. They take input from microcontroller systems, increase its power, and feed the amplified signal to DC motors or actuators. They can also be considered as a DC, direct coupled amplifiers, direct current amplifiers. Some general points regarding the amplifiers. The first two means audio and radio, belongs to analog type, and the last one is a digital or switching system. The PAs for analog designs are operated in A, B, AB, and C. Out of these four, first three types are widely used as audio amplifiers to amplify audio signals. Classes D and E are used for switching operation. In both analog and switching amplifiers, the separation is based on conduction angle. Now, after considering general discussion, overall description of power amplifiers, we move to specific categories. We consider Class A amplifiers, Class A operation of amplifier. In Class A operation, active device is biased such that quiescent collector or drain current is equal to half of its maximum value. Operating point current is equal to half of its maximum value. The RF drive level is limited to cause a swing in the collector drain current that does not exceed its rails, ensuring maximum linearity and output power. Maximum obtainable efficiency of this class of operation is 50%. Notice, out of Class A, B, AB, and C, Class A gives maximum linearity of operation. Of course, at a very low efficiency level. Linearity is maximum in Class A, efficiency is low. So distortion is low when compared to other modes of operation. Efficiency is also. Class A amplifiers, there are two categories in Class A operation: series fed, transformer fed. The load resistance is connected directly in the output circuit of power amplifier in case of series fed. In such case, The quiescent current passes through the load, causing considerable waste of power. When DC passes through load for causing no rise in the signal, no enhancement in the signal, no amplification to the signal, it amounts to wastage. So wastage of power happens in this case. Furthermore, it is also highly inadvisable to pass the DC component when the output device is a voice coil of loudspeaker. When DC passes, noise gets generated. So clarity gets suffered. So it has to be avoided. DC has to be avoided passing through the voice coil of loudspeaker. Now transformer fed class A operation. To avoid the difficulties associated with the series fed connection, a transformer is employed to couple the signal to load. In addition to overcoming the power wastage problem, the transformer coupling has another advantage of driving maximum power transfer to the load. So employing transformer, it gives two benefits. One benefit is wastage of power, it is avoided, it is eliminated. Not only that, with the help of transformer, it is possible to transfer signal's maximum power to the load from the amplifier. In this diagram is shown BJT amplifier with the series load. You see, this is load. This is amplifier, just ordinary amplifier, signal connected. This is coupling capacitor. VBB is bias voltage. Notice load is in the collector circuit. So VCC drives current. The VCC driven current is DC. This DC through RL, it leads to heat generation because of I square R losses. It is wastage of power. And also, as already mentioned, if the load is a voice coil of loudspeaker, flowing DC in the voice coil leads to noise. One more point to be kept in mind is, this point is illustrated in B. Notice the location of operating point. It is at the center of the characteristic. In case of class B operation, operating point is somewhere here. In AB operation, it is somewhere here. In C operation, it is here. So this is A, operating point for A, operating point for B. This is operating point for AB operation. This is operating point for C. Now, another class A mode of operation, transformer coupled class A amplifier. This is ordinary amplifier, BJT amplifier. Input signal is given here. Now, load is here. It is not in the connected directly to the collector. The output is fed to the load through a transformer. As already mentioned, transformer prevents DC entering into load. This is one advantage. Another advantage is, through proper design, it is possible to pump maximum amount of signal from transformer into load. In B is shown same circuit, class A transformer coupled amplifier. Only one difference here, signal input to the amplifier is also given through a transformer. Here through capacitor it is given. Here transformer is used to couple signal source output to the amplifier. As already mentioned, a transformer helps us to transfer maximum amount of power from primary side to secondary side. That advantage can be used here also. It can be taken into account for advantage here also. Some points regarding class A. In class A operation, the effective load resistance is, see, this is the case for transformer coupled amplifier. N1 and 2 These are turns ratio. N1 is primary turns, N2 is secondary turns number. RL is load, this is effective load. In class A operation, efficiency is 25 into Vmax minus Vminimum by Vmax percentage. It is for series fed. For transformer coupled, it is 50 into Vmax minus Vminimum by Vmax plus Vminimum. The quantity that is in the brackets, its maximum value is 1. That is theoretically possible maximum. 1 only. It cannot be more than 1. So maximum efficiency for series fed class A is 25%. Transformer coupled, it is 50%. As already mentioned, it is a theoretical maximum possible values. In reality, the numbers are much less. A few points regarding demerits of class A. It is highly inefficient. Packaging density reduction, another disadvantage. If density is not reduced, then what happens? It becomes a serious problem. To remove heat, to maintain temperature at reasonable values. Wastage of power. Inefficiency means power wastage. Limits battery life. High rise of temperature, unsuitability for IC operation. If you use class A operation for IC fabrication, then what happens is heat generated by the operation of these amplifiers become a serious problem, a complex problem. With this, we come to the end of the session. In this session, first we considered a general discussion on op-amps and then classifications. At the end, we focused on class A operation. Hope this session is useful to you. We meet again with a topic on power amplifiers only, part 2 of power amplifiers, very soon.